I'm head of the School of Public Health and Community Medicine here at the University of New South Wales, and I'm delighted to welcome you all here today to University of New South Wales. I'd like to acknowledge the traditional owners of the land on which we meet, the Bidjigal people of the Eora Nation, and pay my respect to elders past, present and emerging, and note that the land that we're standing on is and always has been and always will be Aboriginal land. It's wonderful to be here, to have the opportunity to welcome Professor Sandro Galea here, and I'm not going to introduce him because Anne Cust is going to introduce him. This talk has been brought to you by the Australasian Epidemiological Association, and Sandro was brought out to Australia by the Australian Prevention Partnership Centre. And I think it's fantastic, and it really is testament to the great collaborations and links that we've got here in New South Wales across all the associations and networks and universities, and it's wonderful to see so many people here. I'd also like to acknowledge that we have a lot of people listening in online, and I'd like to welcome all of you as well. We will have questions later, but you'll have the opportunity to submit questions as we go. Thank you very much and welcome.
Hi everyone, I'm Associate Professor Anne Cust at the University of Sydney, and I'm the President of the Australasian Epidemiological Association, or AEA. And if you don't know what that is, please Google it and then join. I'm delighted that the AEA is co-sponsoring this event with Professor Sandro Galea, who's a physician, epidemiologist and author, and Professor and Dean at the Boston University School of Public Health. And he's also a past president of the Society of Epidemiologic Research, which is based in the US but has a lot of international members. And he was the inaugural president of the Interdisciplinary Association for Population Health Science. So I was interested to see how that overlaps with their SER. So Sandro has specifically asked me not to do a long introduction. So if you want further details, you can read about his biography online, but otherwise I'll welcome him to the stage. Thank you.
Good afternoon. Thank you very much for welcoming me and hosting me here. So everybody has really been very kind during this visit, and thank you all for coming here, both in person and online. And thank you to the Epidemiologic Association for asking me to present while I'm here. I'm an epidemiologist by discipline and trade, but I spend a lot of my time now with sort of at the broader public health world, so it's really always fun to be back and speaking to our own tribe. So I was asked to talk about this title, which I think reflects accurately a range of papers that I've written and talks that I've given over the past probably 6 or 7 years, as I've tried to grapple with the question of how should epidemiology think about itself and how should epidemiology look to the future. And in some respects, the talk is it's a love letter to epidemiology insofar as I actually care deeply about the discipline of epidemiology, and I want it to be better. And at the same time, it's also a critique of epidemiology, because I think there's a lot of things that actually we can and should be doing better. So what I'm going to try to do is try to set the stage by saying there are things that we keep stumbling on, and the reason that we keep stumbling on them is because there are things that we should do better. And then I'll try to propose what I think we should do better, and then of course end with opening it up for questions and challenges. So having said that, let me dive in. Let me just see for a second. Just 1 second. Sorry, this is not the right presentation. That's the right presentation. It's all right, all is not lost. Let me start with the arguments of epidemiologists. So epidemiologists have a... Is there a problem? Oh, that is a problem. I can see them here. Yeah, it's on there now. Is that okay? Should be fine? Okay, very good. Okay, so epidemiologists have, in the past decade, written a whole number of papers sort of critiquing the field and questioning what the field is about, where the field should be going. And I've sort of reduced this into three key questions that I think keeps emerging in the epidemiologic literature. The first question is epidemiology a pragmatic discipline, or is it some sort of broader science? Is epidemiology like astrophysics, in the words of one paper? Or are we ultimately interested in understanding the causes of population health so that we may improve the health of populations? The second question is there a canonical set of epidemiologic methods? Are there a particular set of epidemiologic methods that come from case control studies, cohort studies, and that's all we should be using to answer these questions? And the third question is there a way to reconcile rigorous causal thinking with epidemiology or public health of consequence? And I actually think there's been a whole set of papers written about each of these, and I could give you a summary of all of them, but I will not do that. But I wanted to label these questions right at the beginning, and then I'm going to come back to them at the end, because I'm hoping, in many respects, that by offering some prescriptions for where the field should go, the answer to these questions becomes obvious by the time I finish. The problem with arguing, and actually arguing is a lot of fun, is that while we argue, a lot of things are going on in the world. And many of those things going on in the world are with the health of populations being not up to par and not being as good as it should be. So just a couple of pictures. This is epidemic deaths worldwide, and just to show the preponderance of epidemic deaths in Africa. And the reason I'm showing epidemic deaths, of course, because they should be largely preventable. They're not preventable because we're not paying enough attention to them, and they should be very much in the bailiwick, right in the heart of what epidemiology does. Infant and child death, under 5 mortality in Asia and in Africa. This should largely be preventable. I mean, infant and child mortality has gone down to about 1% of what it was 75 years ago in Australia and in North America, and it should similarly do so here. And then other forces like our sort of ravaging ecological footprint that results in natural disasters, that results in deaths from floods and all that. And I could go on and on to give a litany of all the things that's wrong with health. Now, people who are epidemiologists sitting in the audience, sometimes I get the reaction that says, well, what's that got to do with me? And I would argue that if you are an epidemiologist and you're part of a discipline whose avowed disciplinary description is to understand the causes of population health so that we may improve population health, when we see glaring gaps in the health of populations, it has everything to do with us. It's actually part of our responsibility. And I think thinking that way influences how we think about what we do as a discipline and what the answers to some of those questions that I articulated at the beginning are. And in the American context, I'm just going to show you one slide that I show American audiences, because Americans, as many of you might know, many Americans tend to have this American exceptionalism thing going on, is to remind Americans that this is what's going on in America, that over the past 40 years or so, this is life expectancy, that's US life expectancy. Well, the US was sort of roughly in the middle of high-income countries in life expectancy. Over the past 40 years, we've actually drifted our way to the very bottom. And again, my answer to the question of, well, I'm just an epidemiologist, what does that have to do with me? Well, epidemiologists are ultimately the scientists that are charged with documenting population health so that we can understand its causes so that we may improve it. And insofar as population health is not doing as well as we want it to be, either globally or domestically, in the US or in Australia, then it is on us. So, having framed the arguments and having framed what I think goes on while we're arguing, the question is, why do we argue? And I'm going to make a 3-part argument as to why we argue. I think there are 3 things that we keep that really inform our arguments as epidemiologists. And I think it's important to understand those 3 things because understanding what informs our arguments obviously points towards solutions. So number 1, we argue because we lose sight of what actually causes health. We argue because we lose sight of what causes health. Now, what do I mean by that? I will start by telling you a story to illustrate that. So these 2 generously mustachioed gentlemen are 2 of the founding fathers of public health. The gentleman on the left is Edwin Chadwick. The gentleman on the right is William Farr. William Farr is considered to be one of the founders of biostatistics. Edwin Chadwick was responsible for the British Health Act of 1848, which was really one of the most consequential pieces of legislation in terms of improving the health of the public. Now, Chadwick and Farr have had an argument in the middle of the 19th century. Farr, who was a biostatistician, was counting deaths. So he's creating bills of mortality. And in his bills of mortality, he documented that children who were born to poverty were dying of starvation. So he wrote a report that said, poor children are starving. Chadwick, who was a politician, had a sort of an argument with that, and there's a good quote which said, children do not die of hunger in civilized London. What were children dying of, said Chadwick. Chadwick said, kids were not dying of starvation, they're dying of micronutrient deficiency. Now, was Chadwick correct? Of course he was. Starvation is not magic. It is ultimately nutrient deficiency that causes death. Was Farr correct? Of course he was. Is there a difference, a meaningful difference between their two perspectives? Absolutely. Because if you think that children are dying of micronutrient deficiency, that will point the way to micronutrient supplementation as an approach. If you think that kids are dying due to poverty and starvation, it points the way towards poverty as something that you want to tackle as an approach. And I would argue that this distinction, the distinction between what causes health and us sort of galumphing about with lack of clarity about what causes health is one of the core problems that challenges our understanding in epidemiology. And this problem extends all the way to today. So what causes health today? I'll refer to the United States because that's my home base. If you go on our National Centers for Disease Control website, you find the leading causes of death. The leading causes of death in the United States are heart disease, cancer, chronic lower respiratory disease, accidents, etc. I suspect it's very similar in Australia. Now, the Centers for Disease Control published a paper in the mid-90s that said, well, maybe those aren't really the causes of death. The causes of death are these. They actually are tobacco smoking, poor diet, alcohol consumption, microbial agents, toxic agents, and they quantified the cause of death. That's 1990, that's 2000. And about 10 years later, our group published a paper that said, well, maybe those are not the causes of death. The causes of death are these. Low education, low social support, racial segregation, income inequality, poverty, etc. And these causes here, we're just showing how the number of deaths is very similar to deaths from heart attack, stroke, lung cancer, etc. So what's the leading cause of death in America? Is it heart disease? Is it tobacco? Or is it low education? Well, the answer, obviously, is it's all three, right? The answer is all three. This is a classic causal chain. This is not a black and white answer. It's not a gotcha answer. It's not something you're going to ask your students in a multiple choice exam. Leading cause of death. Is it low education? Is it tobacco? Or is it heart disease? That's a silly question. But the point is that once you understand these causal chains, once you understand that both Chadwick and Farr were right, it does give you a lens on how we should be looking at our inquiry. Because if our inquiry is about understanding the cause of population health, focusing on micronutrients alone is not enough. Focusing on heart disease alone is not enough. Focusing on tobacco alone is not enough. And ultimately, we need to understand the full set of causes that generate population health. Which then, of course, the question is, well, do we do that? Do we do that as a discipline? So in a paper that we did a couple of years ago, we actually reviewed the 5 major epidemiologic journals, American Journal, International Journal, Annals of Epidemiology, and European Journal. These are their papers. You'll see we're publishing more and more papers. And then we created time trend maps of the subjects that we actually publish about in epidemiology. And this is the most recent slice. And essentially, here's what we publish about in epidemiology. Body mass index, a cluster of perinatal, a cluster of cardiovascular risk factor stuff, methods, and a cluster of environmental health stuff. Essentially all risk factors. Essentially what we're publishing in epidemiology is what could comfortably qualify as a risk factor perspective, ignoring the entire rich causal chain that we know ultimately causes health. So we argue reason 1 is because we lose sight of what causes health. Reason 2, when we lose sight of what causes health, we end up focusing on the urgent and not on the important. And there's many, many different ways in which I can show you this, but I'll just show you with one of the 3 most important epidemics in the United States in the past 25 years, and I suspect similarly in Australia, which is obesity. So obesity. So America right now is the most obese country in the world, with about, I think right now it's 36.4% of the population that's obese. By the way, in case you're wondering, the second most obese country in the world is Saudi Arabia, right after the US. And obesity has really galloped forward in the past 25 years. And just to illustrate that for a second, this is a map of the continental US. The darker the color is the darker the obesity. So the dark blue is about 10 to 15% of obesity in the state. That's 1990. That was 2000. And now the yellow is 20 to 25%. And this is 2010, where now the dark is more than 35% obesity. So that's just to give you a sense of the rampaging obesity epidemic. And there is a lot of work on the risk factors of obesity. There's a lot of work that's been done on risk factors of obesity, a lot of work on nutritional epidemiology about the micronutrient equivalence of what causes obesity. But ultimately, the fundamental important driver on obesity, of course, which we seldom study, is the ready availability of calories. And just to give an illustration of that, this is calorie counts on common foods 20 years ago and today. So I don't know how many of you had a bagel for breakfast today. Well, a bagel used to be 140 calories 20 years ago. Today it's 350 calories. And God help you if you had a muffin, because that was 200 calories, now it's 500 calories. And since this is an epidemiology public health audience, I'm sure nobody had French fries, but if you did, that's 600 calories versus 200 calories, and sodas and et cetera, and all that. That is the big difference, that the average American consumes 3,600 calories a day, when an average adult, of course, needs 2,000 calories a day. That is the difference. So America's high rate of obesity is entirely constant with the fact that Americans consume more calories a day on average than all other countries in the world. That is the important, and we lose sight of that when we lose sight of the complex causal chains that ultimately drive health and focus only on the risk factors like the micronutrients. That's the second reason we argue. And this, of course, leads to a problem. It leads to a loss of confidence in our science. Because if we are going to get into these arguments, is it micronutrient A or micronutrient B, at the expense of recognizing that there are these broader factors that cause our health, people understandably lose confidence in our science. And of course, the way to show you that is using where all wisdom resides, namely in Twitter. This is from an economist who said, if you think economics is a mess, read the medicos. He means us trying to figure out if we're eating too much salt or too little. And the way I see it is, when economists are making fun of you, that's when you know you're in trouble. Just to give another sort of sense about, I think, the pitfalls of thinking in a narrow way and the risk factor pitfalls, is this cartoon, which I really like, where the square peg goes, with a proper diet, moderate but consistent exercise, and the development of a healthy mindset, I should fit into the round hole just fine. That is what risk factor thinking makes us do. So my setup is it time for the end of a risk factor approach, is that, well, a risk factor approach, it gets us in trouble. It makes us argue, and we lose sight of what causes health. It makes us focus on urgent and not on the important, and essentially has people losing confidence in our science. So a possible solution that I've pushed forward in the literature is something which I've called the causal architecture approach, which I'll explain in a second. But ultimately, a causal architecture approach opens up the way for us to think about population health science comprehensively, and I would argue helps obviate some of these questions. The paper where we articulated this is this paper, which is called Limits of Risk Factors Revisited. Is it time for a causal architecture approach? And in this paper, we argue that a causal architecture approach is as follows. It's a focus on theorizing about the prevalence of causes and their co-occurrence across populations. And the key here is co-occurrence, using innovative methods, using representative samples to understand the role of context to shape the health of populations. That is ultimately what we say is a causal architecture approach. Now I want to break up the definition a little bit and talk about pieces of it. And let me start with this, which ultimately a causal architecture approach theorizes about the prevalence of causes and their co-occurrence in populations. Now this is actually quite important because this leads us quite astray from where risk factor epidemiology is. Risk factor epidemiology ultimately is about identifying and isolating single causes for point diseases and trying to find the single cause that we can act on. The causal architecture approach is interested in the prevalence of causes and their co-occurring patterns as they cause complex diseases, which is a substantial difference. And this is grounded in an understanding of population health science, that ultimately the health of populations comes from complex systems called populations, and that we need to understand these principles of population health science to advance our thinking. So the principles of population health science can really help in this way. Now, what are the principles of population health science? Well, in a book that I wrote a couple of years ago with my good colleague Catherine Keyes, this is the book, we talk about population health science as the study of conditions that shape distributions of health within and across populations, which, as you'll see, has echoes of this notion of a causal architecture approach. In it, we articulate 9 principles of population health science, which you can't read, that's okay. But what I want to do is I want to illustrate what I mean by this by focusing on 3 principles. I want to talk about just these 3 principles that I'm highlighting in red to give you a sense of how thinking about the health of populations and the complexity of causal interlinkage and causal co-occurrence can help us understand things about health that we otherwise cannot. So let me talk about each of these principles in brief. I'll start with principle 1. Principle one, which when my colleague and I were writing this book, we argued about because we thought it was too obvious to actually put in as a principle, but in the end, I'm glad we did because I think it was the most important thing that we put in there, was that we need to think of health not as a dichotomous, but as a continuum. Now, this is, of course, very far from where epidemiology is at, because we are habitually, reflexively dichotomizing variables and putting everything into 2x2 tables if we cannot all help it. But why does thinking of things as a continuum help? Well, here's an illustration. Let's look at BMI for a second to stick with obesity. This is body mass index. This is the population curve for body mass index. And what we are accustomed to doing is to thinking about obesity, drawing a cutoff at BMI of 30 right there and dealing with the people to the right of the line. Of course, in so doing, we entirely forget the fundamental principle, as initially well articulated by Jeffrey Rose, which is that represents a distributional shift in populations, that by looking only at the BMI over there, you're forgetting the whole population and where the whole population sits at. This kind of dichotomous thinking makes us forget the difference between individual and group prediction, and makes us forget that actually we care as much about people where all people are, where the whole population is, as we do about people who cross some threshold. Just to give you a concrete illustration of that, let me talk about something that we all know in our minds as epidemiologists is a risk factor. And let's take cholesterol. So we all know cholesterol is a risk factor for heart disease. Everybody here is very sophisticated. There's different kinds of cholesterol, good cholesterol, bad cholesterol, etc. We all know that, but just work with me, cholesterol. The understanding of cholesterol as a risk factor comes from the Framingham cholesterol risk equation, which actually comes out of the Framingham study, which is run by my university, Boston University, hence I feel like I can pick on the home team. The Framingham data and the Framingham cholesterol risk equation showed that cholesterol is a risk factor for heart disease, which triggered, of course, a multi-billion-dollar global industry of cholesterol mitigation, right? There's an enormous medical industrial complex about cholesterol. Now, where do those data come from? Those data come from the Framingham data, and they look like this. These are the Framingham curves that show people with high cholesterol, low cholesterol, heart disease, no heart disease, and they look like that. So this is real data. The black line is people without heart disease, and the dotted line are people with heart disease, and this is cholesterol at the bottom. So when you look at those curves, what's the first thing you notice? Well, the first thing you notice, of course, is how similar those curves are, right? That they look almost the same. And you say, how could these two curves have been the curves that have launched 1,000 ships of the medical industrial complex about cholesterol? Well, the reason they have is because we've dichotomized. What's that mean? Well, we create a cutoff right there, and we count. We count D and A. D is with heart disease to the right of the line, A is without heart disease left of the line, et cetera, create a 2x2 table. A times D is bigger than B times C. We have a positive and odds ratio which is more than 1, ergo, we have a risk factor. That is risk factor epidemiology, and that is risk factor epidemiology which comes at the expense of understanding population health as a continuum, which ultimately is fundamentally how health is expressed. Now, is this a real concern? I'm just picking on cholesterol, but people in this room, just doing a hand wave, have collectively published thousands and thousands of papers. And how many of our papers actually have been about risk factors? Well, actually all of them. But how many of those papers have been about risk factors in such a way that they actually allow us to come up with population curve separation, that allow us to distinguish between populations rather than risk factors that exist because we dichotomize and are ultimately at the margins? So the way to answer that question, I'll ask you to check your own papers. What relative risk do you need to achieve curve separation, to allow you to distinguish populations rather than have the curve overlap like this? Is it 2? Is it 4? Is it 10? Is it 20? The answer is you need a relative risk factor of about 350 to have curve separation. And don't take my word for it, this is from a great paper from Margaret Pepe and her group. Raise your hand, how many of you have published a relative measure of association of 350? Oh, somebody in the house in the back. I have not. What outcome was that, sir? Yes, it's very good. Yes, it's that would do it. There are a couple of other unusual papers like that, but that's correct. This is actually the first time that anybody has actually been in the room who's been in the Kaposi-Sarcoma paper. The other one, the other classic is is vaginal adenocarcinoma, which had an infinite risk factor, because in a case control study of that, there was nobody in the denominator. It just does not happen. Like, this is not what we do, right? And this is a mismatch. It's a mismatch between how we think, how the field thinks, and how populations are really structured. So one principle that's useful is think of population health as a continuum. Second principle. Now remember, going back to my definition of causal architecture, we're interested in causes and their co-occurrence. So the principle is, then when we're interested in the effect of an exposure on an outcome, we need to focus on how factors interact on other factors that interact with the exposure. So to illustrate that, I thought I would ask a question. So you're all here on this lovely day on the afternoon listening to a talk about epidemiology. So let's assume that, unless everybody sort of is motivated by some delusion, that everybody here is smart and cares about these topics. So I would like to ask you this question. How much of your cognitive ability, your smarts, cognitive ability is just a nice way of saying brains, is determined by your genes? So let's make this assumption. Let's make the assumption that two things matter for your IQ. One is some gene, some genetic complex. I'm not saying a single gene, some set of genes. And the other one is your environment, right? Genes and environment, they both matter. So my assumption is that they both matter. Everybody get that assumption? So my question is now very simple. What percent of your smarts is due to your genes? And I would like everybody to answer that in their own head. And then I'm going to come back and we're going to revisit the answer. But everybody needs to be honest about their answer. Assumption, genes and environments both matter. Question, what percent of your brains is due to your genes? I want to make sure everybody has an answer in their head. I won't make you write it down. You need to be honest. Yes? Heads nodding? Everybody has an answer? Okay. So let's do the math. Let's take a population. Here's our population. And schematically, just to make it easy, I'm going to show you the people with the smart gene as being black. So when the figures become black, they have the smart gene or gene complex. When the figures are in the green, they're in a smartogenic environment, good parents, et cetera, et cetera, et cetera. And I said gene and environment both matter. So when you're black plus green, you become red, which is smart, right? Cognitive ability plus. And just to make the math work, so I don't have zeros in the denominator, I'm going to toss in these 5 are going to be random smart people that are going to be tossed in, because we all know smart people who are really smart, and you look at their parents, you're like, and they grew up in a terrible place, you're like, how did they become smart? So there's always some randomness in all of these. So let's do the math. Here's the scenario. Let's take an environment, which is a very positive smartogenic environment. So it's really almost all green. The black, which is where the genes are, I'm showing it to you as dotted now, just so you can see it behind the green. So, and these are the random smart people. But the black plus the green is going to become smart. That becomes red. So what's the proportion of smarts that due to genes? Well, notice that everybody with the gene, everybody who's black, has become smart, which means that the relative risk of smarts given the gene is 1, is very high, and the PARP, population triple risk proportion, is 1, which because everybody with the gene became smart. Let's take a different scenario. Now, it's a limited smart environment. You see it right here. Same gene pattern. The black is still the same, but only 2 of the genes are now with the green. Those 2 become red. So what's the relative risk of being smart given the gene? That relative risk is 1.7, and the population risk proportion is 40%. So the answer to your question, what percent of your being smart is due to your genes, given the assumption that both genes and environment matter? The answer to that question is, I cannot tell you unless you tell me about the environment. Okay, raise your hand. How many of you said that answer? How is it possible? I told you the assumptions, right? How many times did I tell you the assumptions? 3 times. I said genes and environment. Notice I kept saying it, 3 genes and environment. Notice how conditioned we are in doing this. By the way, I present this not infrequently, and every single time I come up with a percent answer in my head, even though I know it's wrong. I'm actually not tricking you, right? I said the assumptions are genes and environments both matter, and I said, tell me the percent that your genes are responsible for being smart, and we all come up with a percent answer. Why do we do that? Because we are so conditioned to thinking that we can isolate single causes. When in fact, there's nothing special about this math. This is all math you can all do on the back of a napkin. This is like elementary epidemiologic thinking. And we all know this when we think about it, but we do not think about it because we focus on how we're conditioned. So what's the point I'm making? The point I'm making is very simple, is that you cannot really think about these causes in isolation, because when you have causes that are co-occurring, right? I said genes and environments both matter. You have to think of both co-occurring causes. And by the way, this is not just theoretical. This we see manifest in nature all the time. Is this all theoretical? No, this is actually from work by Eric Turkheimer and his group looking at the changes in the genetic variance on IQ by SCS. So this is actually well documentable. This is well documentable that ultimately the contribution of genes and environments, and I could show you this for obesity as genetic forces modified by physical activity and on and on and on. Therefore, the point is that under the plausible assumption of co-occurring causes, notice this point, the plausible assumption of co-occurring causes, any given sample is going to give us different estimates for genotype-phenotype association or for cause X and cause Y, whatever it is, unless we look at both the X and the Y. In order for you to say that I am going to isolate a single cause and come up with a robust, consistent estimate of the proportion of an outcome depending on a cause, you have to be able to say there are no co-occurring causes. Unless you can make that argument, the rest of it collapses. And I would challenge us to saying that with the rare exception, and the point that the gentleman there made about sort of Kaposi sarcoma, in particular case of some rare cancers, there are almost always co-occurring causes, which means that we need to think this way all the time. So let me go back to obesity. I made the point about calories. Obesity are important co-occurring causes. This is the food environment, which is ultimately what determines calories, right? And the food environment co-occurs with areas of low education, for example. These are co-occurring causes that if we want to understand epidemics like obesity, we need to bear in mind. The third principle I want to talk about. Small changes in ubiquitous causes may matter more than substantial changes in larger causes. And this is, in some respects, self-evident, but also something that we forget all the time. And when we do not think this way, it distracts us from fundamental ubiquitous causes. And just to illustrate this with one example, this is the crack cocaine epidemic of the mid-'80s in the United States, which resulted in the epidemic of research on this notion of crack babies. This is Tom Bracco, one of our newscasters, talking about sort of how terrible this is. And the story was that poor moms, many of them black, were having these babies, and these babies, the crack that the mom was using was neurologically impairing the babies. And there were all these sort of videos of jittery children and all that, and it was clear that these kids were developmentally quite a bit more delayed than non-crack kids, until, of course, cooler heads prevailed about a decade later, and study after study showed that actually there was no real difference developmentally in these kids. So the question was, what was going on? What was this influence of crack? Was it crack cocaine? And scientific consensus eventually gelled around the fact that the gestational crack exposure really was not doing anything at all. So why did we think there was something wrong with these kids? Well, there was something wrong with these kids. It had nothing to do with the crack cocaine. What it had everything to do with the fact that these kids were born in abject poverty, in terrible environments with terrible environmental stimulation. This is from a longitudinal study showing this was ultimately environmental stimulation that was driving these kids. Of course, we did not see that. Why did we not see that? Because these kids being born in poverty and terrible environment was ubiquitous. They all were. They all were. And it was easy for us to focus on looking at variability in how much crack they had been exposed to gestationally, rather than notice the environment that was ubiquitous for all of them. So ubiquitous environments really drive a lot of population health and should influence how we think about when we're trying to think about the causes of population health. And in some of our writing on this, we've been using this term about focusing on what matters most, which is quantifying what matters most to the health populations, and ultimately these ubiquitous forces inevitably are what matters most. So number one, if we want to realize a causal architecture that shifts epidemiology forward, we need to focus on these principles that think of epidemiology as serving the health of populations. Point two, we actually cannot do all this simply by focusing on our typical epidemiologic methods, and we should be open to embracing other disciplines, data, and approaches to understand the mission of epidemiology. Now, I could talk about all the disciplines that we could embrace, but I'm not really going to do that. I'm happy to do it in the Q&A. But I will point out that we are actually not very good at doing things outside of our comfort zone. The bottom line is that the majority of epidemiology uses one method and one method alone, which is regression models. And just to show you that, these are the, I want to tie tying it back into the definition I gave you before of causal architecture using available innovative methods. This is 1 year, the last year, 2018, published in the American Journal of Epidemiology. These are the papers published, and we pulled all the methods, all these papers, and all I want to show you is that about half of all the papers use regression modeling. About half the papers use one approach that dominates our entire field. And that approach, of course, has one thing in common. It is predicated on the notion that you're isolating the effect of one cause, holding all other things constant. That is what that method has in mind. And that method, that approach, is what dominates our field because it's consistent with us seeing isolating risk factors as central to what we do. Then the other thing, just another part of this analysis is we looked at the sample sizes that were used in 1 year of papers in American Journal of Epidemiology, and it's about 4 quarters. You see the papers under 10,000, under 1,000, under 10,000, 10 to 50, and about a quarter papers more than 50,000, which is good. I mean, this is good for epidemiology, as everybody knows. But in a world where we're dealing with big data like this, where you're dealing with billions and billions of data points that are available to us, it to me speaks of the fact that we as a discipline have not quite had the comfort to immerse in a world where we use the data that are available to us to answer questions that are important, not simply urgent, but also important, using a mindset that is open to beyond thinking about single risk factors. That's the second point. And the third point is, if you think this way, it also forces you to rethink how we teach the next generation. It does push us to think about teaching epidemiology differently. And going back to my definition of how one thinks about causal architecture approach, part of it is using things like representative samples and understanding the role of context in shaping the health of populations. And we do not teach the next generation using things like this. So how do we teach epidemiology? Well, for a discipline that actually has a bit of a cottage industry of epidemiologists questioning how we do things, we are sure very confident of ourselves in how we teach. So we did this analysis of textbooks of epidemiology, and what we did here is we looked at the topics, definition, disease transmission, disease frequency, study design, cohort, case control, etc., and we looked at the percentile of the book in which they fell. And all I want you to see is the dark line across here, and the dark line means that we actually teach these same topics in the same order in all the major epidemiologic textbooks, which means, of course, that we think that we have this all figured out. The problem with this is that this represents a bringing together of insights from multiple different theoretical evolutions. Things like case control studies and cohort studies and the methods used for those are actually quite different. And the fact that we bring them together and put them together in the same textbook represents a marriage of convenience rather than a wholesale articulation of principles in the field that we come to from a place of understanding the field. So I think there is a better way of doing it, which is to think about fundamental concepts in epidemiology and developing those fundamental concepts so that students grow up with a more intuitive sense of understanding the causes of disease and grappling with the complexity of causes within a causal architecture framework. We try to do this in our book, Epidemiology Matters, trying to reframe around core principles and talking about this is ultimately how we should be approaching epidemiology. We start from a sample, we start from a population, conceptualize what we're trying to do, estimate measures of association, use causal thinking around that, bring the causes together and make sure that that matters for whole populations. Now, I would argue that all of you would roughly agree with this last sentence that I just gave you, and all of us would roughly agree that that's what we're trying to do in epidemiology, but in doing what we do, we seldom realize the potential of that sentence. So I just want to show you 3 particular examples of how we teach epidemiology. Talk about sampling, generalizability, and the extent to which that leads us to do work that is work of consequence. So let's talk about sampling. How do we teach sampling typically in epidemiology textbooks? Well, we usually have separate chapters on cohort studies, case control studies, RCTs, ecologic studies, Some books talk about a population base, but few, if any, books talk about the need for representative sample. Why? We do not talk about representative sampling because we ultimately do not see that as important, because we see external validity as secondary in importance to internal validity, despite the fact that without thinking about sampling, you actually cannot generalize the populations and come up with knowledge that is consequential for populations, which is ultimately what we should be about. Sampling can be taught by always focusing on the populations and explicitly talk about the benefits of representative sample versus purposive samples, things we don't do. And we can do it in a way where we actually graphically introduce the student to an intuitive sense that ultimately epidemiology should be about taking samples of populations so that we can learn things that apply to the population itself. So that's how sampling can be taught. Now, how about generalizability? Generalizability is typically not taught at all. Typically, it's used to emphasize internal validity versus external validity, and typically brought up as a secondary concern to internal validity. How should it be taught? I think it should be a first principle, because when you care about populations, we want our samples to get us information about populations so that we can then infer about whole populations. Now, I will point out that this is actually quite controversial. This is a paper in International Journal of Epidemiology, which is now edited by Steve Leader, who's here, about making the express argument, not only that representativeness doesn't matter, but actually representativeness is a bad thing. Written by a faculty member in my school of public health. So you can imagine the conversations about that. And we can talk about this, but ultimately the conceptual divide here is between saying epidemiology is a discipline that cares about using tweezers to isolate a particular risk factor so that we can actually do something about that risk factor, controlling for everything else, or saying epidemiology is a field that recognizes dealing with a complex system, with a set of complex populations, and dealing with the complex causal architecture that produces health in those populations. And third, as an example, how do we teach what epidemiology matters, epidemiology of consequence in most epidemiology textbooks? And the answer is we actually don't. We do not bother with that in most epidemiology textbooks. We actually have we pay very little intellectual energy to the question is, are we doing science that matters for the health of populations? In a paper that I wrote about 6 years ago, where I make this argument for consequential epidemiology, I argue that we should be teaching our students to be able to evaluate what matters most, what causes matter most, how do we balance the needs of comparability and external validity, how do we deal with small effects and the big implications of small effects, and to be careful but confident in articulating the intervention implications of our work. So I'll sum up, and I will sum up by going back to the questions that I said epidemiology argues about. Remember I said we argue about these three questions. Are we a pragmatic discipline or a theoretical discipline? Is there a canonical set of epidemiologic methods? And can we reconcile rigorous causal thinking with public health of consequence? So the answer, I think, to these emerge naturally from an approach like this. The answer to the first question is both. Yes, it is a science. It is a science of population health. And it is an approach to understanding the complex set of causes that drive population health, but it does so to the end of generating science that can inform public health. It is a population health science that aims to help us understand the complex causal architecture so that public health can then implement and improve the health of populations. Second question, is there a canonical set of epidemiologic methods? And the answer is, I think no, not at all. I think we should use any means necessary. We should use any approach that lends itself to answer difficult questions about the complexity of causes that drive the health of populations. And can we reconcile rigorous causal thinking with public health of consequence? Absolutely. I see no reason why not. I think once we understand that to do a public health of consequence, you need to grapple with a complex causal architecture, and you need to understand how that ultimately shapes the health of populations, the two are totally reconcilable. That's really it. And in some respects, what I've been trying to do is trying to bring all of these pieces together. And I will end with perhaps one of my favorite lines in a rebuttal for a paper of mine, which was actually the causal architecture paper that I was asked to talk about, which is this, which says these views position the authors far outside the epidemiologic and public health mainstream. And I will leave it to you to judge whether or not I am outside the epidemiologic or public health mainstream. But maybe we can have that in our Q&A. Thank you very much for having me. It's a pleasure to be here. Here we go.
Thank you very much, Sandra. That was really stimulating talk, and I hope that everyone's got some questions. So we're going to have questions through the Slido app. I think someone was going to put something on the screen. Yeah, okay. So you can post your question there. And people that are listening through the live stream can also do that. And someone will be moderating any crazy questions, although Sandro has said that he's quite interested in hearing crazy questions, so I'm not sure if they'll sneak through. And I will try and pick some questions for interesting discussion. After this, this is due to finish about 5:30, and then outside the room there'll be some books that Sandro's written that you can have a look at and buy if you're interested. And I also, while I've got the floor, wanted to make a plug for the World Congress of Epidemiology, which we're hosting in Australia next year in Melbourne. And abstracts are open at the moment until the end of February. So just a reminder to think about that and get your abstract in. And
are people in the room allowed to raise their hand, or no?
Well, I
is
don't
it against
think
the
so.
Slido rules?
I think they're not allowed to. Yeah.
It seems you're at a disadvantage for having shown up. Sorry.
All right. So there's a question here, a more statistical question. Did your IQ example exhibit the epidemiologist's preference for multiplicative models and interaction terms, bypassing consideration of additive models?
Yes. Yes, it's an illustration. You can do the same. You can make the same kind of illustration with additive models, but yes, that example was purely multiplicative.
Okay. While I'm waiting for more questions, I've got a few. So. You put up a slide talking about how we teach, what we teach in or a few slides on what we teach in epidemiology. And in terms of the methods, you say essentially 50% of the teaching is around regression. And there's less teaching around things like policy and simulation. Do you think that the way epidemiology is taught in schools of public health need to shift to enable a more
I do think that we need to decouple our teaching away from a dogmatic loyalty to particular specific methods to a more conceptual teaching that allows our students to understand that epidemiology is about populations, that what we're trying to do is try to sample populations because we cannot count the whole population. We want to count within that sample. We want to infer causal associations within that sample so that then we can actually come up with answers that we can do something about. And I think if we can actually embed that kind of logic in our students, it will serve them very well 20 and 40 years from now when we actually have no idea what the methods are that they're going to be using.
So at Boston University, where you can influence things, presumably, how are you changing the curriculum there?
Yeah, it's an excellent question. I would let you have the conversation with your dean about the extent to which the dean can directly influence such things. We actually, for our master's students, we have moved away from epidemiology masters. We now do epidemiology and biostatistics together, and we have created a hybrid curriculum of epidemiology and biostatistics that aim to guide the student to thinking through these principles. And there is no one textbook that's used. We use a pastiche of textbooks.
Okay. Colleagues from public health are already thinking we in epidemiology are being too quantitative. How do we encourage discourse about this?
Yeah, it's a great question. If we have a moment, I think it still does this. If you Google qualitative epidemiology, what you get from Google helpfully is it says, did you mean quantitative epidemiology? I mean what I said when I think the answer to the questions about the causes of population health should be obtained by any means necessary. And I think qualitative approaches have a place there. I'm not sure exactly how to wrap my brain around qualitative approaches within the canon of methods, but if you go back to what I was saying about the principles, that our principles are, we care about populations, we care about understanding the full set of causes that drive health in populations. We want to take samples to illustrate those causes, use whatever methods we can to understand the causal effects so that we can do something about it. I don't think that precludes qualitative methods at all.
So what are the implications of your proposed approach for people conducting intervention studies, where often the focus is on changing sort of single factors?
Yeah, I think it's a really important question. I think people who do things like pragmatic trials are onto something in that they are trying to figure out how we can create trials that are rooted in the real world and that can bring about change, that actually can make a difference in the real world. I think the fundamental counterfactual premise that you can have a trial that represents all things in the world being equal, except for one variable that we're changing, is problematic, particularly when the samples that we use for trials are almost never representative of broader population.
So talking about representativeness of studies, there's a question here about how do you obtain a representative sample these days?
I feel like the audience is in a different place than I am because they're reading questions behind us, which I can't see. So I don't know what you're all thinking.
So how should we obtain a representative sample now when it's getting harder and harder to do that? What do you consider a reasonable response rate these days for a study?
Well, let me answer the first question first before I answer the second one. I think there are plenty of approaches to get representative samples using digital approaches, using a combination of digital list-based approaches, using approaches that deal with cell phones. I think we actually don't think about it at all. I actually think epidemiologists, we do not spend any time thinking about how to get representative samples, and we leave that only to sort of the lesser species like survey methodologists, and we don't really pay much attention to that. And I think that should be part of what we think about. The answer to what's a response rate, I don't know how to answer that. There is no such thing as response rate. There are dozens and dozens of different ways of assessing participation in any representative sample, and I think there is no such thing as an adequate response rate. I think it really depends on a whole range of factors.
So how do you determine then whether a sample is representative or not?
Well, no sample is ever adequately representative. What really matters is what are the criteria on which the sample differs from the general population, and whether those criteria, most importantly, influence the effect of interest, which sometimes differences in sample do not really influence the effect of interest. So that's what really matters.
Okay. How can you speak to the role of other disciplines to work in collaboration, especially in relation to second principle regarding conceptualizing exposures and indicators?
Yeah, I think it's a very good question, and I think it's very hard for epidemiologists to contain the multitudes within us that say that we can conceptualize and adequately measure all variables of interest, particularly if I'm going to be saying that we should be thinking about the full causal architecture, because ultimately the set of variables that really matter draw from a broad range of disciplines, and I think we do need multidisciplinary help to articulate those variables. So if we're interested in discrimination, one would argue that we need input from sociologists, and if we're interested in molecular determination, one would argue we need input from molecular biologists, and I think we should be open to that input from multiple disciplines.
Will your approach make it easier or harder to explain health risks to the general population and decision makers?
Well, I think it makes it, I think at one level, it makes it harder because it's easier to say blueberries bad, strawberries good. But I think it makes it both more honest and gives us a more durable solution, because every single time we say blueberries bad, strawberries good, tomorrow we'll go out and say, oops, changed our mind, blueberries bad, strawberries blueberries good, strawberries bad. So I do think it might be harder to give a story of complex causation, but it is a more accurate story and not one that we have to keep changing every 5 minutes.
In relation to the obesity story, how do you think the way epidemiologists approach problems, it's largely due to their training? We're not really taught to tackle complex problems which, are very political and involve skills outside of our training.
Absolutely.
So I guess this comes back again to how to train the next generation of epidemiologists, but yeah, how would you propose to an early career researcher who was working in obesity what they should be focusing on?
I think an early career researcher focusing on obesity should be making sure that she understands the full set of drivers of something as complex as obesity. One can look at a complex system map of obesity and recognize that there are literally hundreds of factors that matter in terms of driving obesity. And a fruitful career is one that looks at the interrelation between variables and how those interrelated variables drive obesity rates in populations. And I also think that a researcher needs to understand that the epidemiologist is not necessarily doing it alone. This goes back to the multidisciplinary point, that to understand something as complex as obesity, food subsidies matter for obesity, and it's likely that an economist needs to partner with an economist to do something about that.
So I think that's related a bit to this question about what are the methodological implications of this approach and what are the tools that we need to implement it. So obviously working across multiple disciplines is important. What do you think are the key other disciplines that epidemiologists need to work with?
I think we need to work with the full range of disciplines that are concerned with the health of populations, and I think that ranges from demographers to sociologists to anthropologists to economists, just to name a few. So I think there are plenty of other disciplines who are interested, and I've learned over time that an exciting next generation is far less disciplinarily bound than is perhaps an older generation.
Your introduction raised the importance of addressing health inequities. We know a lot about its causes already, and what needs to be done. Is precision a diversion?
I'm doing a talk about precision medicine tomorrow, so I'm not really sure I want to give away my whole story there. But I did not talk much about health inequities, although I did hint at it. So let me talk about health inequities for a second. I think one of the crying shames of the state of health populations right now, be it domestically or globally, and by domestically I actually mean American as well as Australian, is enormous health gaps and enormous number of people who are health left behind. And that is a real crying shame, and I think it's an abdication of our responsibility to improve the health of populations, whole populations. So health inequities should be a focus of what we do. I do think precision is a diversion, yes. I do think it's a diversion because I think there is no demonstrable benefit of a genomic medicine approach, none actually, and I'll discuss that tomorrow. And I think it diverts us from far more important issues.
Okay. How would your approach shape how you would advise US authorities to respond to the current US opioid epidemic?
Yeah, I think it's a very good question. I think the opioid epidemic is a classic case of an epidemic that's fueled by inattention to fundamental ubiquitous causes. I think the solution to the opioid epidemic needs to be broadly less availability to opioids and more availability to solutions to help people move beyond the epidemic. That means more solutions to treatment, the destigmatizing of drug use, the availability of alternatives to incarceration. All of that needs to be widely available and needs to be much more available than opioids themselves. And right now the balance is totally the other way around. And I hope that people hearing that will recognize that will be consistent then with the epidemiologic approach I'm advocating for.
Many major population health influences are outside the health sector, for example, commercial influences. How can epidemiology embrace these external sectors more effectively?
Yeah, I think epidemiology does need to embrace these external sectors, and I think the answer to how is through intellectual inquiry that has a broader lens than our current lens. I think the commercial sector is a good example of that. I don't know exactly the full suite of epidemiologic approaches that lend themselves to understanding the commercial drivers of health, but I would be excited to learn from a generation of epidemiologists that sees that as part of its remit.
Regression modelling currently dominates EPI. What analytic methods are underused and can inform your causal architecture approach?
I think there are a full range of methods that are slowly burgeoning. The one that I've spent most of my time trying to figure out how it fits in epidemiology are simulation methods using systems approaches. And I think that has promise because it allows us to think of whole systems and think of a full set of complex causes that intersect in an causal architecture approach to drive the health of populations. In no way do I think that's the be-all and the end-all. I think it's simply one approach, but I think it's a full set of approaches from systems dynamics models to agent-based models to microsimulation models that allow us to think of whole populations. I do not think that approach should become 50% of epidemiologic papers either. I just want to be very clear. I actually think a full, rich set of epidemiologic analyses would have no majority method and it would have a diversity of methods to address a diversity of complex problems.
So do you think people, when they write a paper, should have a range of methods in there?
No. I think one paper should have one method.
Right.
That's only as much as I can handle. I don't know, maybe you're all just much, much smarter than I am, but I can only handle one question, one method in one paper.
Well, sometimes people publish mixed methods papers, I guess, with some qual-quant, but
I find those papers not very clear.
Okay. Is public health epidemiology stuck at estimating average causal effects? In the C21 century, for 21st century, should the aim be heterogeneous effects and personalised public health?
I loved that question until the last three words. I think the answer about heterogeneity effects is it's a really interesting question. Some of the favorite papers I've ever been involved in have been about heterogeneity of effects and trying to understand heterogeneity effects and the causes for heterogeneity effects, which I think reflects ultimately heterogeneity is the population shadow of complexity of causation. So I think that's actually a very interesting approach. I don't know that will lead to personalized public health. I actually think that will lead to an understanding of the complex set of interactions that results in outcomes that manifest over a range of extremes, and that ultimately is all about the multiple variables that co-occur and that interact with one each other to result in a heterogeneity of outcomes. But I'm not sure that is going to result in a personalized public health because I think individual prediction is far beyond the scope of what population health science ever will do.
Can people and media deal with complexity in explanation? Just taking the climate change debate as an example.
Well,
you can have a break and have a sip of water if you need at any time.
No, I'm good. Can people in media deal with that? Well, I think there are different ways of answering that. I think the easy way of answering that is to say no, that people in media can't do that, and that's their problem. I think a harder way of answering that is to say it's our fault if we cannot explain ourselves clearly and give people in media ways to understand complex answers. So I think the current answer is no, that we are doing a bad job of conveying complex ideas to the media. But I think a lot of that responsibility is on us, all of us, myself included. And I think we need to learn how to get better at translating our message.
Do you think all epidemiologists should get media training as part of their coursework?
I think all institutions that are responsible for academic population health thinking should have as part of their mission the translation of the science that is produced in their walls at the institutional level. At the individual level, I am very comfortable with having epidemiologists, individual epidemiologists, who are allergic to media and to translation and who simply want to lock themselves in their office and do good science, as long as they allow the institution to translate their work. So I'm not sure that it's productive to say that all scientists need to engage with the media. I think that's why we exist in institutions. If you're going to be a lone epidemiologist working in your own shed at home, I suppose you have some responsibility beyond that. But assuming that most of us work in institutions, I think it's a group responsibility to translate our work. I'm not sure I want to impose it on individual scientists.
So another media question. You mentioned we have access to social media data in today's world. How do you suggest incorporating it into your causal architecture approach?
Well, I think data are data. I think data are a tool, and I think the larger the data set, the more potential there is to take a complex set of variables, apply them to the data to try to understand what is driving outcomes in the data set. So I think large data sets that come from social media provide a wealth of information about behavior that clearly epidemiologists, we are behind on. I mean, if Amazon knows what you want before you know what you want, you know that they're using better methods than what we're using in our papers.
Research on the causes and consequences of poverty are many. Is there a need for epidemiologists to enter this area of research?
I do not think that epidemiologists have any place in research on the causes of poverty. I think epidemiologists have a place in research about the causes of the health of populations. And if poverty is a cause of the health of populations, then it should be something that we concern ourselves with. I think the causes of poverty, it's a totally different question altogether. I don't hear health in that. I think we should stay out of it.
Okay. When we take a focus on population health, we can't ignore the complexity and interactions of the social determinants. How do you quantify those?
How do you quantify the social?
How do you quantify? Yeah,
Just
I guess
social
you
terms?
did, at one point you had some percentages up.
I did.
Yeah, how did you quantify them? Well,
I'm not sure I understand the question. I mean, you measure them the way you measure anything else.
yeah, I mean, this is asking how do you quantify the social determinants of health?
I think I would push back on the question because I don't think social determinants are that different than other determinants. I mean, it's like asking, how do you quantify behavioral determinants? I mean, you do the same thing we always do, which is you say, let's understand the cause, let's figure out a construct to measure it, let's figure out a way to measure the effect it has on the outcome using our tools, and that results in quantification. So I think we should be careful about not putting social determinants in their own particular bucket. I think they're determinants like everything else.
I think the other, I guess in the question it's asking about the complexity and interaction, so perhaps they're getting at, that everything's sort of related, there's a lot of related aspects, and how do you tease those apart?
Yeah, I would argue that there are a lot of related aspects in everything we do, and this goes back to sort of my co-occurring causes example, that ultimately there are related aspects in everything we do, and the same methods should apply to causes that are outside the skin as causes that are inside the skin. By disciplinary label, I'm probably a social epidemiologist, and I've argued that the term social epidemiology should go away. The reason the term should go away is because social epidemiology implies that there is a specialness to social causes, and I don't think there is. I think causes are causes are causes, and we should treat them all the same, and we should apply the same critical lens to all of them, be they social, be they exogenous, be they endogenous.
So should every epidemiological paper come with an explicit DAG, and maybe you can explain to the audience what a DAG is in case not everyone knows, or several? Yeah,
so the DAGs, which are directly cyclic graphs, are essentially causal diagrams. And I think the cutting edge thinking and teaching in epidemiology is that the answer is yes. Whether explicitly every paper needs to have a causal diagram in it, or that causal diagram should be informing what we're doing. I'm not sure that every paper needs to have a diagram formally in it, but I do think it should inform our thinking. So the answer is, that yes, I think anything that we do in epidemiology should be informed by clarity of thought about the underlying causal architecture of what we're trying to do, and an explication of that underlying causal architecture to the end of illuminating part of the diagram so that others can fill out other parts of it.
Can I just expand on that around the teaching of causality? Because the traditional teaching of causality, at least when I did my MPH, and it's still around today, is around the Bradford Hill criteria of causality. And, you know, DAGs, I think they're used a lot more in the US, but they're starting to be used more here. How do you teach causality at Boston University and more broadly across the US, and has that changed over time? Yeah,
I know. I think broadly speaking, I think the Bradford Hill criteria had heuristic value in terms of helping us understand what might be characteristics of causes. I think out of the 9 criteria Bradford Hill articulated, only one of them truly is a characteristic of a cause, which is not a very good hit ratio if you think about it. But I think causal thinking is very much moved to a place of thinking about understanding the underlying causal diagrams, be they DAGs or be they some other approach, and applying the best methods possible to understanding those causal diagrams. I don't think that is a US-based approach. I think that's actually where the field is going.
Is stratification a way forward rather than throwing everything in a model?
I think stratification is helpful. I don't think that any finding that emerges from a fancy model is worth its salt if one can't show it through simple approaches, including stratification, and then using the modeling to more robustly test what you're observing simply. But stratification is a very useful approach to simply articulate what you're looking for.
What is the role of data science in a causal architecture approach?
I think epidemiology should be upset if we do not think of it as a data science. We deal with data, yes. We are a science, yes. So why should we be forfeiting data science to the computer scientists, or God forbid the economists? We are a data science, and we should be proud of that, and we should adopt our approaches to inform data science. We ultimately are about understanding the causes of the health of populations, and the more data we can use to answer that, the better.
Can you provide an example of how you have applied the causal architecture approach?
Yeah, I'll give just one example where we were interested in how to mitigate. A lot of my own work has been around violence and trauma and mental health consequences of violence and trauma. So we did a series of papers trying to say, how do you mitigate the mental health consequences of violence and trauma? And we tried to look at different intervention approaches, particularly to narrow racial group gaps in the mental health consequences of violence and trauma. And then we realized that you actually cannot do that without also dealing with underlying forces of population segregation that shape racial patterns that we're seeing. So the causal question was, what is the influence of trauma on mental health differences in black-white groups in the presence or absence of different levels of racial segregation? That then becomes a causal diagram. That then allows you to apply different methods to try to answer the causal question. So I'm using that as I'm trying to build it up as a nested set of questions that once the core question is trauma equals mental health. The second question becomes trauma equals differences in mental health. The third question is, you actually can't even investigate the trauma equals mental health differences between different racial groups until you understand the underlying distribution of those racial groups, which then creates the full causal set. And that's how we approached it in those papers.
So then the approach would be around starting with some more descriptive epi in particular subgroups, and then
always, and then using more complex models to address the more complex questions.
Mm-hmm. If Amazon does it better, as you said, do you see a role for tech companies in public health?
Mm-hmm. Yeah, I do, and I think it would be a mistake for us not to learn from our colleagues who bring perhaps more computer science approaches to data science that can lend itself to understanding the health of populations, whether it's the companies themselves or whether it's the approaches that are used by the companies. I think if epidemiology is the science of understanding the health of populations, we should use whatever methods we can from any discipline we can, and if some of that comes from the commercial sector, why not? I am aware of the moral compromises, etc. We can just to label that. I am aware of that. I'm happy to address those questions. By the way, are people here sending questions there, or is people here just like being quiet, listening to questions coming from elsewhere?
Well, I mean, presumably the questions are coming from
here. Are you all typing questions? I'm just curious. You are? Okay. It just seemed rude that you're all just listening. Just want to make sure that you actually have a chance to ask questions.
Well, if they're on their phones, it's probably because they're typing a question, right?
Oh, I thought they were just bored.
Deep in us, we want our contribution to be of consequence. How can we make our epidemiological contribution more consequential?
Yeah, I think it's a great question. I actually think that this is why many of us are drawn to epidemiology, because let's face it, because you have people who are interested in health and who are number nerds, and as a result, we're drawn to the field. And so I think it's great. I think it's a real pity not to do epidemiology that one feels is consequential and is contributing somehow. I'm not saying that every paper or even every 100 papers need to make a difference. I'm simply saying that we should be bearing in mind what matters to the health of populations and doing work that pushes us in that direction. And that I think it's egosyntonic with why we went into epidemiology to begin with. So I think it's something that we should all be happy to be doing. And I think it is. I have yet to meet an epidemiologist who says, no, I actually don't really want my work to matter. We all want our work to matter.
Other science fields might avoid consequentialism as they can't predict what is later consequential. Example, new mathematical proofs. Should this be considered?
Yeah, I think so. I would answer this in the same way I answered the media training question. I'm very happy to allow a range of engagements by epidemiologists and to say that epidemiologists should have the reign to do work for the sake of advancing the science without seeing immediate application. I think consequentialism needs to have immediate application that's nakedly visible today. I think that's okay. I'm not sure that mathematical proofs are quite in the same realm of what we do, but I think it's important that the work that we do at least bears in mind what matters to health populations so that we are intersecting with that, because that ultimately is our mission.
So how can we remove race from epidemiology? It's a very poorly defined concept and something we can't change.
Yeah, that's a great question. So anybody's interested in that question specifically, again, I'm like very confused as to where the question is coming from, you all or somewhere out there. We actually have a paper that just came out yesterday, literally just came out yesterday, called Reconciling Social Epidemiology with Causal Thinking, where in it, with Professor Miguel Hernan, who's at Harvard, we try to grapple with the question of how do you deal with social forces from a rigorous causal thinking perspective. And we use race as an example. But just to give you sort of a quick summary, the paper literally just came out yesterday. We talk about the fact that it's actually very difficult to grapple with race from a causal thinking framework, that ultimately we should be thinking about are the forces that race generates, things like racism, which are much more easily conceptually manipulable than our forces like race. The paper also has 3 commentaries that go with it, which don't like the paper. The American Journal of Epidemiology.
Okay. Should we stop calling ourselves epidemiologists? Maybe population health scientists, especially if the methods we embrace encompass more than epi approaches. And I guess this comes to I had another related question was, you know, you were a past president of the Society for Epidemiologic Research, but then an inaugural president of the Interdisciplinary Association for Population Health Science, which you could argue would be part of the SER, but has become a separate association. And so, what do you see the difference between population health science and epidemiology, and do you think there need to be different associations?
Well, I'm not going to comment on the associations part because I don't want to get in trouble with my friends. But I will comment on the field. I do think, I'm trying to think of how radical to be.
You can be very radical.
Because I'm in Australia?
You're far away from all your...
Although
they won't be live streaming because it's the middle of the night, probably.
That's right, nobody's paying attention on the other side of the world. You know, if I had my druthers, and if anybody would publish it, I would write a paper that said, epidemiology is dead, long live population health science. And what I mean by that is that I do think that the goals of epidemiology can be subsumed in population health science. I think that takes nothing away from epidemiology. I said at the beginning, my talk is intended to be sort of a love letter to epidemiology. It's a discipline which I've resonated with and which I've lived my adult career. But I actually think that the goals of epidemiology perhaps are better served by casting ourselves as population health scientists. We're interested in the science of population health, and that allows us to open up our scope to a broader range of methods than the ones within which we have been disciplined as through our training, those of us who are in a room like this.
And then maybe our family members will understand what we do as well.
It does seem easier. You don't have to worry about the overlap with sort of epidermis and dermatology. See, it makes things so much easier. And not just that, you can then tell your colleagues that you are a basic scientist. You do population health science, a basic science. So like the pros are enormous. All you have to do is just change your business card. It's a small price to pay.
So there's not much time left, maybe a couple more questions. So there's a question about that little is done in the field of immigrant epidemiology, but I guess you could also apply this to other fields where there's little amount of work done, but that might be quite important to health. And how can we encourage more work in those areas?
Yeah, I think it's a terrific question, and I think whoever asked that question is thinking the right way. I actually think we should be asking ourselves, what are the forces that drive the health of populations that we do not understand well enough that we may do something about them? And if immigration is one of them, and I would argue it is, then that is space for work. Mental health being another one. Mental health is vastly understudied in terms of its impact on the health of populations. And so this is like if there are students in the room. If there are students in the room and you want to find a place where you can make an impact, you take an area that matters, where very few people have been doing work. I would argue that immigration and mental health are both such areas.
How do you see knowledge from community, especially communities experiencing marginalization, as influencing epidemiological designs?
Yeah, I think it's a great question. And I think that goes a little bit to the previous answer I just gave, which is if you're trying to identify what matters, the question is, where does that knowledge of what matters come from, right? It comes from two places. One, it comes from, well, I guess it comes from one fundamental place. It comes from learning. And learning comes in multiple forms. You can read about things. You can listen to community members, right? You're learning about what matters. So I think community voices have a role in informing your understanding about what matters. So I think in that vein, community voices really matter. I have a caution about community voices because not infrequently we're dealing with community voices. We are dealing with very select voices that do not necessarily represent the concerns of a whole community. So I think we have to be very careful about that. But assuming that one can truly understand what a population, to use the term population sort of community, considers important, then I think they can be very informative to our learning, absolutely.
Well, that's the last question, but I might ask one last question, which is not necessarily related to epidemiology, but you obviously, you've got a lot of papers, you've written books, you travel the world and give talks. My question is about time management. And do you have any top tips for managing your time?
I have one tip that somebody once told me. Never try to remember anything you have to do. So I have a running list that I revisit dozens of times a day. So if you were to tell me right after this, hey, can you do X? I will immediately write it down. Do not try to remember it. Put it on my list. And this way, it frees up so much cognitive energy. Then you can write all the papers and the books you want. That's all I got.
Okay.
Thank you.
Well, thank you very much, everyone. outside, you can peruse the books, and feel free to, Sandra will be hanging around for a little bit, so if you want to come up and ask any other questions, I'm sure he'll be willing to chat. Thank you very much. Yeah, was it? You did really well.